All right, so a few problems for you. Find the function with the given derivative whose graph passes through P. I got this question. Somebody said, well, can I just go and do the whole linearization thing? L of x equals dot, 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 dot. And say, I don't see anything in there about linearizing this. And this is a bit of a trick question. This is basically saying, find the antiderivative. It doesn't say that, but that's what it means. So this is the kind of problem that when you get to the next unit will be a lot more clear. All right, so how do I find the antiderivative of negative 17 over x squared? Well, first off, let's write it as negative 17 next to the negative 2. Find a derivative I, throw it out front, and subtract 1. So we do the opposite of that. To find the function, we add 1 and divide by that. And then we have to put this constant out here, plus c, because we don't know if there was some constant when they took the derivative. All right, so 17x to the negative first plus c. Prove it. Well, let's take the derivative. Derivative would be negative 17x, subtract 1 negative second. There it is up there. All right, how do we find the c? Well, that's what this point up here is for. So 23 equals 17 times 1 to the negative first plus c. That's just 1 minus 17 from both sides. And we get c equals 6. So there's our function. P of x equals 17 over x, or 17x to the negative first, plus 6. Do another one. Now I've got two different problems here because somebody asked me to do a slightly different one. Maximize a rectangle under this, find dimension area, yada, yada, yada. So we get this kind of shape. And we want this rectangle here. All right, this is x, this is y. This is also x. So area of x comma y equals 2x times y. 2x times y. Let's write that in terms of x. 2x times 49 minus x squared equals 98x minus 2x to the third. How do I find a max or a min? We take the derivative and set it equal to 0. So a prime of x equals 98 minus 6x squared equals 0. Move that over, we get x equals the square root of 98 over 6. Now, I'm actually not going to do the other problem, but the other one that somebody asked me for was y equals 81 minus x squared. And you can see you would sub that in here. All right. This is not even remotely done. They want the dimensions of the rectangle. All right. So first, let's just do y for the fun of it. So the y value is 49 minus the x value, square root of 98 over 6 squared, also known as 49 minus 98 over 6. Now, AP standard, and I got my calculator out here, is 49 minus 98 divided by 6, 32 point this. So we would go with 32.667. 3 decimal places for AP standard. Okay. However, I believe in the Math Excel problem here, it asks for 2 decimal places. So read the full question, but if it doesn't say, then go to 3 decimal places for the AP. Now I'm going to leave all this up there. We have this tendency to hit clear like 90 times. I'm going to leave it all up there. The x value, pardon me, the base of the rectangle is 2x. So 2 times square root alpha y equals, get me a decimal bar, 98 over 6. Gets us 8.08. So the height, I'll call it, equals that. The width equals 8.083. Now you could have also written 8.082 because the AP allows truncating. Again, on the Math Excel, they wanted 2 decimal places, do whatever they say, nothing else to bring up. What's the actual area? Area equals, now you're probably worried about rounding here, and you should be, that times that. So I pull the exact numbers off, hit enter, I get 264.042. All right, so that is how I would do it on a test. This one's ludicrously straightforward, even though the math is kind of hard, because you'll see what I mean in a second. 2 sides of a triangle, 6 and 13, theta. There's this other side over here. I don't care. I need the height. Call it h. Height over 13 is sine of theta. Sine of theta is opposite over hypotenuse. Opposite over times 13 times 13. Now I got the height. Area is 1/2 the base, 6, times 13 sine of theta. Area is 39 sine of theta. Area prime is 39 cosine of theta. Set it equal to 0, and you get theta has to equal pi over 2. How come? That's cosine, that's pi over 2, that's where it equals 0. So when you slow down and you think about it, yeah, right, that's going to maximize the area if that's a right angle. Duh, but that's how we do it. Theta equals pi over 2. Use differentials to estimate the maximum error in area measurement, yada, yada, yada. All right, area of a circle, pi r squared. dA equals pi times 2r dr. Pi times 2 times 40 times, what's the highest error? Well, if I make this positive 0.2, it's going to give me error. It really should be an absolute value, and I can put in positive or negative, it doesn't matter. Blast it out. Pi times 2 times 40 times 0.2. 50.265. Now that seems insanely high. That's dA. But yeah, that's what you get, unless I screwed up. Nope, that's right. All right. You can do this the long way if you want. That's the correct answer because it says use differentials. But you say the actual area is pi times 40 squared, which is 5,026.5. I'm just ballparking this for now. Well, no, I said I'll do it right. 548. And the area when we screw up and make it 0.2 bigger is pi times 40.2 squared. We take this and subtract that, and we get 0. Well, that was weird. We take this and subtract that. Aha, there we go. We get 50.39. Subtract and we get 50.39. Remember, this is using differentials to estimate. So that's our estimate. This is what it actually would be. And you can see doing the differentials is a lot easier. So that's why we do that. I already did this one. Did I? Oh, guess I got them all. Weird. Put that one underneath. And that's it. Good luck.